Hello everyone, we are from Northview Secondary School. Our project is on energy efficient diagnosis using qPCR. Cancer diagnosis involves resource-intensive procedures such as tissue biopsies or X-ray, and when cancers are relatively inaccessible, for example brain tumor, we use high-energy imaging equipment such as MRI and CAT scanner. However, these machines can only be performed on one patient at a time. Furthermore, they use a lot of energy, time and money to run with MRI scanner using 1.3 kilowatts and CAT scanner using 3.8 kilowatts for a single phase. Not to mention the addition of the amount of energy required for the facilities and personnel supporting them. Moreover, this method can only detect late-stage tumor where patient survival is poor, and the amount of energy required to support the treatment of advanced cancer is very high. What if there was a non-invasive blood test-based method of diagnosis that used less energy? Could we use a molecular diagnostic tool that can detect cancers at an earlier stage? Recent studies have pointed to the feasibility of using quantitative polymerase chain reaction to detect the rise or fall in specific molecular markers such as microRNAs, which have been found to be abnormally regulated in cancers. By using this method, we are able to test more patients with lesser personnel. Thus, lesser energy is used. Furthermore, it is able to detect early-stage tumor where patient survival is high. Lesser energy is also needed for treatment when the tumor is at its early stage. The graph here shows the comparison of energy, time and cost used on each method. Now, let's take a look at the graph. From the graph, we can see that the energy consumption is very high for the MRI and CAT scan compared to a PCR test. Even though the time consumed for every method is relatively the same, the cost needed for a PCR test for a single person is very little compared to the other two methods. Thus, we are able to diagnose cancer with lesser time, energy, and cost. A good biomarker for cancers would have a large change in concentration in the blood in patients with tumors. To model this, we investigated microRNAs secreted by three brain tumors, namely U251 and LN229 gliomas, and a neuronal cancer NT2. We detected the microRNAs both directly from cells and also tried to detect if these microRNAs were secreted by the cells into their growth media. We were able to detect all the microRNAs directly from cells using qPCR, but some were not detectable in growth media. This could have been because we diluted the growth media too much that the particular cell lines used did not secrete the microRNA tested in large amounts. MicroRNA 302A and MicroRNA 302B were particularly interesting as biomarkers, as it was clear that they were easily detectable even though we had greatly diluted the media before testing. The next logical step would be to determine if these two microRNAs are also detectable in the bloodstream of patients with this form of cancer. We also like to find microRNAs with a similar profile for gliomas, which we could find given a larger testing panel. In conclusion, using microRNA to detect the brain tumor is a more energy saving as less time is needed to do a PCR test on many patients compared to the CT and MRI scan. Furthermore, the power consumption of a CT scan is also more than a PCR test. Thus, we conclude that a PCR test is more energy saving, cheaper, and less time consuming compared to a CT scan. We would like to express our gratitude to Associate Professor Tu Huing Fon for the use of equipment, reagents, and laboratory space, and our mentors Sarah Ho and Zhou Li Han. Thank you.